Yeah, thanks for coming. Maybe we should have brought the drinks already here to get more people motivated. But yeah, of course, it's the afternoon dip. So yeah, good that at least some of you made it. Trustworthiness is in everybody's mind and mouth, and I want to go a little bit deeper into what we mean with this and how we can tackle the challenges that are included. A little bit outline. So I want to talk to you about trust in general, what trust is, and also mention a little bit some ideas that are active in the EU with respect to the regulation of AI. Then talk about hybrid AI in two different meanings, because it's a bit of a vague term, but I will make it a little bit less vague than it is. And then give you an example of causality at the end. So what is trustworthy AI? As one definition, we could say that AI systems are trusted when we have confidence in the decisions that they take, and that means that we understand why those decisions are made. But how do we get there? So trust is not something that we just develop as a component and put it into a system and then it's trustworthy and we're done. Rather, trust is a property that will emerge based on different aspects, and I mentioned a few here. So important aspects of trustworthy AI systems are, for example, fairness, robustness, transparency, verification or verifiability, and accuracy. So, accuracy, of course, is also important because if the systems don't perform as they are expected in terms of just giving the right results, then also fairness is not a big issue. With respect to fairness, I would like to make an important remark here, because what I mentioned here as one of the aspects also of fairness is bias that is also discussed a lot. And it is always seen as something negative. So getting rid of bias is often cited as a goal. But in fact, this is completely the wrong perception, because what we need is not removing bias. What we need is creating awareness for bias. So if we don't have any bias in data, we basically also have no information. So bias is actually what we want and what we need. The problem that we have with bias is only that it can be implicit, and then we get into trouble. As an example, I was working on a project a while ago on predicting diabetes, which worked very well. We had a lot of data to train the system for, and predictions were really good for a certain population, namely white men of age 50 plus in a certain region. So if you apply the same system trained on those data to black women somewhere else, you can, guess that it will not be as accurate as it should. So, but if you know that, and if you have the training data and they match the application that you want to use it for, there is no problem at all. Then actually the bias is a positive thing. So yeah, I just wanted to mention that because there's often a confusion about this. So if we look at trust itself, and we look at how it is related to AI, I make a definition here of AI as automation that is attributed with intent. It's a term that we come to see more often in the rest of the presentation. Then we see that actually there are two parts to it. So we have two roles. We have a truster and a trustee, where the truster is usually the user, and the trustee is the AI system that we want to trust. And then there are two aspects. One is the trustworthiness, which means that the system itself is trustworthy if it operates according to the requirements. So if it operates correctly. The other side is that the user can trust a system. So that is the perception of the user of the system. And yeah, I put this on the next slide. Maybe that's better to show. There is this relationship between the trustor and the trustee. And if you want to make it even more concrete, there's also this notion of warranted trust, where you actually have a contract, an explicit contract of what the system should do with respect to the user. And yeah, what is important here is that there is a certain balance between the trusted part and the trustworthiness part, which means that this is also called the trust calibration, which means that they need to be in line. So if we have a trustworthy system that is not trusted, then we would not use such a system because yeah, we don't trust it for some reasons, although it would be trustworthy. So that is under-reliance. If we have the other aspect, so we trust the system, but it's actually not trustworthy, then we have over-reliance, and then we use such a system, although it doesn't work properly. So in both cases, we can have too much trust or too little trust, and both are problematic. What is also related to this is a distinction between intrinsic and extrinsic trust. So how do we define that? Intrinsic trust means that we actually understand how the system works internally. So we really can see how it is operating. We can understand its processes and the results. Extrinsic trust, on the other hand, is more like we trust someone else that this system is acting properly. Or we've been using it so many times, it always worked, so we still don't know how it works, but we still trust it. Both are possible, and they're also a bit linked to another big theme, which is explainability. So also there you have this notion of explainability in the sense of that you understand the internals of a system, or you trust in someone else understanding it. The big problem there is that if there's nobody who understands the system, which is often the case, then you're still in trouble. So you can trust someone else, but yeah, if there's nobody who really has insight, then yeah, you're still not much further. Yeah, and you're not supposed to read this. I just want to show what is going on at the moment in the EU. So there is a EU regulation being prepared that basically asks for certification of AI systems so that they must be trustworthy. Otherwise, they're not allowed to be marketed. And they have their own definition. There's a basic set of requirements. So it must be lawful, ethical, and robust. All very nice terms, but yeah, still very vague. And then they have a bit more explanation of what that means in a bit more detail. So there's the whole list here. And even this is still yeah, very high level, very abstract. It doesn't tell anybody how to implement this. How do you verify that all of these aspects are actually built into a system? So that's still a very active discussion that will go on for the next couple of years, probably until this legislation will be enforced. An interesting aspect, again, you don't need to read all of this, just to show you what the thinking is there. What they do is they look at risks of AI systems. So they define 4 different levels of risk. So you have the systems, the green one with the minimal risk. You have the red one at the top, which they call unacceptable risks. So these are applications that are just forbidden, like killing robots, that kind of things. Then there's some with the limited risk, which are have some requirements with respect to transparency. But the most interesting one are the ones with high risk. So those are the ones that can actually make damage to human life, either physically or in related things like losing all of your income or something. And there they have a list of application areas where such high-risk systems are expected to be developed or are being developed. Just mention a few here. So critical infrastructures, education, safety components of products, also employment, public service, law enforcement, border control and migration, and justice and democratic processes. That's their list. So yeah, you see that if something goes wrong in those domains, then really in trouble. And they expect that there will be a verification, validation process in place to make sure that before you put such a system in operation, it will avoid all those risks. So much for now about trust. If we look at how we can get towards trustworthy systems, one approach that we're following is, it's called hybrid AI, but hybrid is a bit of a vague term. So what I mean here is a hybrid in two meanings. One is the human-centric approach, so where we look at how do intelligent systems cooperate with humans, especially in human agent teams. So agents are software components, autonomous software components with AI that can perform tasks on our behalf. And so we can work together with them in teams. We're looking at multi-party decision-making there. And also the theory of mind, I will talk about this in a moment in a bit more depth, is of importance. And then the other aspect is the integration of different methods of AI. So you're all familiar, of course, with the last decade dominated by machine learning and deep learning. But if you know AI a little bit longer, you know that there have been other approaches before, and well, they still exist, and they all have their advantages and disadvantages. I will come back to that later as well. But the integration of all those approaches is what we think will be one means to achieve trustworthiness. So if we look at the first aspect, so the human-centric AI, we also call human empowerment, because the aim here is not, as is often seen in the press, that AI will become self-aware and conscious and dominate the world, and humanity will vanish. Well, at least for me, that's not. Well, it's not a goal, and it's not anything that we wish to create. I also don't think we will in the next couple of 100 years. But so, well, I wouldn't worry too much about that. So we prefer to say, well, we want to support humans instead of replacing them. Talking about the symbiotic coexistence of biological and artificial intelligence. And using their complementary capabilities. What that requires is mutual awareness of each other's capabilities. So we need to explicitly state what the intentions, what the goals, what the facilities are of each other, of humans and of software agents, in order to make this interaction fruitful. So they're all individual knowledge, etc. All the things I mentioned, and also we can model and be transparent about the expectations and intentions of mutual partners in such a hybrid team. So yeah, that's basically it's also a very fundamental software engineering principle that to make all assumptions explicit. So the more explicit something is, the more you can verify it. You can be aware of it. You can explain why certain decisions are taken and actions. And part of that is also this theory of mind, which is a principle from psychology, but is also very much used in multi-agent systems. So the idea there is that when taking decisions, when reasoning, each party in this community or in this team does not only reflect upon its own knowledge and goals, but also the intentions, goals, and capabilities of others. So if I know that that you know that I know, then I think differently. So my decision will be influenced by the state of the whole group. So that's well, very important to have this also included in meaningful interaction with AI systems. All right. Then if we look at the second part, the hybrid AI in the sense of multiple paradigms of AI or methods, there is what is called now a third wave of AI. There are many different ways of calling it. What we see is, of course, that AI is much more than just machine learning or deep learning. There are many other techniques that can be used. And we see that current AI systems that are only used based on learning are basically, they're brittle in the sense that can make mistakes, unexpected mistakes, very, very easily. They're narrow. They have only one specific task, and they are opaque in the sense that they're just black boxes. We don't know what's going on, and all of these are big problems. So there is this new wave of saying, well, let's not rely only on this approach, but also on what has been done decades before, which is sometimes called symbolic AI, knowledge-based AI. So there is terms used nowadays as such as neuro-symbolic, which tries to combine this. And there's a lot of discussion and literature about this appearing the last couple of years. And there's also evidence that also from psychology, for example, the famous book of Kahneman, Thinking Fast and Slow, goes very much in this direction that also the human mind has separate systems. One is more the reactive system that is fast, but there's not much thinking going on. And then we have this the slow, the cognitive capacity. Cognitive capacity of actually reasoning about the knowledge we have attained, and these two work together. You cannot live with only one of those. I think I'll move on. Not sure how I'm doing with time, by the way. But here's another table to compare these different approaches, what the pros and cons are. And the message here is basically they all have problems, but let's combine the advantages of the different approaches to come up with something that is both knowledge-driven, so we reuse our knowledge that we already have. We don't need to learn what we already know, to make it more trustworthy also, because we rely on, for example, our knowledge of physical laws. They have been around for hundreds of years and seem to work. So why should we start learning them from data? So it's more efficient also, we need less data, it's more reliable, these kind of ideas. But on the other hand, we also want to have learning systems combined with knowledge-based systems, because they can, not everything is written down as laws and rules. So we also need the flexibility also to update the knowledge. So altogether, there are three main aspects: so learning, reasoning, and acting to AI systems in contexts. Am I running out of time? 2 minutes. Okay. Okay. Let's see. Yeah, so these aspects, well, I've been talking about this, I think, enough. I want to give an example. This is just one slide out of a longer presentation, which is based on a paper that you might find interesting about design patterns for neurosymbolic AI systems. So it's a paper we wrote 2 years ago. You see here a representation of one of such a hybrid system with the different symbols have different meaning. There's also a whole taxonomy to unify the language, how we talk about even those systems, which is was quite a challenge to come up with. But what you see here is an application of where on the left side, the left gray box, is a machine learning approach. So we have data that is used for training. We create a statistical model. We have other data that uses that model to deduce a symbol in this case. What we do here is, for example, recognizing handwritten digits, which is, of course, well-known application. But we don't only want to do that. We also want to do arithmetic on those. And yeah, would you do that on the basis of bitmaps? Learning bitmaps to add or multiply, or, well, it seems like a stupid idea. So what we do is on the right-hand side, we have a semantic model which we use to do the multiplication or the addition. So we do that on the symbolic side. And in this way, you can combine the strengths of both worlds. Yeah, it's much more reliable, robust, and also trustworthy in the end. And this is actually an approach that was also used for AlphaGo, which they wouldn't say. So yeah, I have time for this example. Totally, well, not totally. A related aspect is also what is called causality. So there is a big difference between correlation and causation, which means that typically what you do with machine learning is correlation. So you find patterns in data, you find certain things happen often together, so they must be related. In this case, there is a high correlation between sunburn rates in July and August, but also ice cream sales seem to be very high at that time. So they must be related. Now you could conclude without further thinking that, yeah, if you don't want to get sunburned, then don't eat ice cream. Which of course is complete nonsense, because what is happening is that there is no causal relationship between the two. But there is a third aspect, which is of course the sun. So the sun is the cause for both of those effects. So they are correlated, but they're not causally related. There's another picture to show the same. Yeah, and there's a whole theory of causation nowadays, yeah, this thing happens very often, where the third event or whatever is called a confounder, because it yeah, it influences the other two that look like they are one causes the other. All right, so not too bad. Just to show this is a recent article I wrote for our for our newsletter. You can find it on the web. If you look there, and you find a little bit more information and contact info. yeah, and if you ever happen to be around in Saarbrücken, come and visit and let's chat. So.
Thank you.